Hello, in this worked example, we're working with a truss structure. So this is kind of a lifting structure mounted with a pin joint at A and a roller joint at B. And we're asked to find the forces acting in each of these members. So in this truss, we've got a total of 7 different members. I've already got them labeled over here. So as we figure them out, we can kind of fill in what we know about the forces acting on those. So each of these is going to be in tension or compression. It's either going to have the two ends being pulled apart or the two ends being pushed together for compression. So we need to label those as we go. The first step in any of these calculations is going to be to go ahead and find the reaction forces. So at point A right here, we've got a pin joint, which means that we've got a force possibly in the X and possibly in the Y. It's preventing motion in both of those directions. And at point B, it's a roller, so it can't prevent motion up and down, but it can prevent motion left to right. So it's going to be exerting a force possibly either to the left to the right or to the left. So let's go ahead and analyze this whole truss structure as a rigid body first. So drawing out that shape, we've got something that looks kind of like this. And we know we have a 500-pound force acting down on this end. So our reaction forces were at point A, and we've got an X and a Y up at point A. So R AX and R AY. And then down here at point B, we know we've got a force only in the X direction. RBX. Alright, so some of these distances, this distance right here is going to be 6 feet. And if I look at my original diagram, this distance from this 500-pound load all the way over is going to be 12 feet. So now I can start solving for some of the unknowns. So I can do sum of forces in the X, sum of forces in the Y, and sum of moments about some point. So if I do sum of forces in the X, I'm going to have RAX plus RBX plus nothing else is equal to 0. So RAX plus RBX equals 0. Sum of forces in the Y, I've got RAY minus 500 is equal to 0. And then finally, sum of moments. I'm going to take the moment about point A right here. So about that point, I've got the 500-pound force. So sum of moments about point A. The 500-pound force is causing a negative moment using my right-hand rule. And it's going to be 500 pounds times 12 feet. And then I've also got this RBX. So RBX is exerting a positive moment, and it's going to be the magnitude of the force RBX times 6 feet. All right, this is negative plus RBX times 6. All right, so I can immediately solve some of these things. If I've got RAY is going to be equal to 500. And then I solve the moment equation. RBX is going to be equal to 500 times 12 divided by 6. And that's going to give me a value of 1,000 pounds. And then finally I can plug that into this top equation. RAX is going to be negative RBX. So RAX is going to be negative 1,000 pounds. All right, so let's go back to this diagram over here. And I can put some of these in. So RAX is going the opposite direction of what I thought, and it's going this way with 1,000 pounds. RBX is going this way with 1,000 pounds, and RAY is going upwards with 500 pounds. Alright, so now that I've found the reaction forces, I can start looking at individual joints in the method of joints. So I'm going to erase some of this to make some space. And I'm going to start by looking at point B. So point B is down here at the base. I've got a reaction force that I know, and I can figure out the force in member AB and the force in member BD. And so at 6 feet tall, 6 feet wide, this is going to be a 45-degree angle. In fact, all of my angles in here, if they're not directly horizontal or vertical, end up being 45-degree angles. So looking at point B. And again, point B, that's this point down here, has a 1,000-pound reaction force to the right. So in addition to the 1,000-pound reaction force to the right, I'm also going to have FAB, I'm assuming tension, that's pulling up. And at a 45-degree angle, I've got the force FBD. And that's from members AB and members BD. I'm assuming tension in both of these. So I've got my setup. Let's go ahead and solve sum of forces in the X and sum of forces in the Y. So sum of forces in the X. 1,000 plus cosine 45 times FBD is equal to 0. So if I do sum of forces in the Y, I've got FAB plus cosine or plus sine 45 of FBD equals 0. All right. So cosine 45 of FBD, or I could solve this top one for FBD. So FBD is going to be equal to negative 1,000 over cosine 45. And that gives me a value of negative 1,114, negative 1,414.2 pounds. 1414.2. All right, so there is my first value. I know the force in member BD is 1,414.2 pounds. And the negative indicates that this is going to be, my initial assumption was wrong, and this is going to be in compression. So member FBD was 1,414.2 pounds compression. All right. So next, let's go look at member FAB. So FAB is going to be equal to negative sine 45 times FBD negative 1414.2. So double negative, that'll cancel out. And I should end up with a final value here of 1,000 pounds. So that's a positive number. That's going to indicate tension rather than compression. So this is member AB, very top of the list. All right, so now we need to figure out where we're going to go next. So we found the forces, number AB and BD. Next place we can go up to point A. We can figure out the forces in members AC and AD next. So if I draw out my diagram for point A, I'm going to have forces, I'm going to have reaction forces in two of those directions. Let's give myself a little bit of room right here. So the reaction force is pulling back this way, and I've got a 500-pound force pulling up. I've got FAB. I know that value, that's pulling down. It's a tension force, and that's 1,000 pounds. And then I've got my two unknown forces. So FAD is going to be pulling to the right, and FAC is pulling up at a 45-degree angle. And again, like it was earlier, these are all 45-degree angles. All right, so here I'm going to do sum of forces in the x, sum of forces in the y. So sum of forces in the x. I'm going to have negative 1,000 plus FA, or plus cosine 45 times FAC plus FAD equals 0. In the y direction, I'm going to have 500 up, 1,000 down, plus sine 45 of FAC. Positive 500 minus 1,000 plus sine 45. Let's move this down to the next line. Times FAC. All right, so I can solve this bottom one for FAC. And if I do that, I should end up with FAC being equal to positive 707.1 pounds. And my value for F, and then I plug that into my top equation, and I find a value for FAD being equal to 500 pounds. So both of these end up being positive. They're both going to be in tension. So this is 707.1 pounds tension and 500 pounds tension. All right, 3 more to go. And we need to figure out where we're going to go next. So now we know the forces in member forces in member AD and forces in member AC. We can go a couple different places. I chose point D next, so we can figure out CD and DE. So at point D, I've got a known force, and member AD, again, that was in tension, so it's pulling. The magnitude of that force was 500 pounds. I've got FBD, that was compressive, 1,414.2 pounds. So if it's compressive, it's going to be pushing on that point. And then I've got FCD, which I don't know, so I'm going to assume tension. And then I've got FDE. I don't know that one, so I'm also going to assume tension. And then also, this angle right here, as always, is going to be 45 degrees. So at this point, I want to go ahead and write out my equations. Sum of forces in the x is going to be equal to cosine 45 of 1414.2 minus 500 plus FDE. Sum of forces in the y, I'm going to have sine of 1414.2 plus FCD equals 0. Alright, so I can pretty easily solve for these two things. And if I go ahead and plug in this to my equations, I should end up with FDE from this top equation. That solves out to negative 500 pounds. So that's going to be compressive force since it's a negative number. And FCD, for my bottom equation, if I solve for that, it's going to be negative sine 45 times 1414.2. FCD ends up being equal to negative 1,000 pounds. All right, so two more unknowns solved for. Let's go ahead and plug those in. There's FCD is 1,000 pounds. FDE is going to be 500 pounds, and both of these were compressive. So CE was 1,000. And DE was 500 pounds compression. So last one to solve for. We've solved DE, CE, we just need to solve for CE. So we go to either point C or point E. The one I ended up choosing is, I went to point E. So looking at point E, this is where my load is applied. So I had a 500 pound load pulling down, and that's this load right here. I know the force in member DE, that was compression, it was 500 pounds, so it's going to be pushing. And then finally, I've got member CE. I don't know that. I'm assuming it's in tension. And it's at a 45-degree angle. So at this point, I can go ahead and choose either one of the equations. So I can do sum of forces in the x, sum of forces in the y. I only need one since there's only one unknown to solve for. So I went ahead and did sum of forces in the y. So sum of forces in the y, it's going to be sine 45 of FCE, or times FCE, minus 500 is going to be equal to 0. If I solve this out, it's going to be negative, or correct, 500 over sine 45, FCE equals 500 over sine 45. And that's going to be equal to 707.1 pounds. All right, and that's a positive number, again indicating tension. And so with that, I've got my full problem. I've solved for all of the forces and all of the members, so they're either in tension or compression, and my results are over here. So we've solved our problem. Thank you for watching, and I hope to see you again.